Welcome to the Exec Exchange, 15-minute podcast in which a leader from the water sector shares a story to inspire, educate and inform other water sector leaders from around the globe. My name is Piers Clark and my guest today is Harry Sachinis from EYDAP, the Athens Water and Wastewater Treatment Company. Harry, wonderful to have you with us today.
Great to be here. Thank you, Piers, for inviting me.
Now, you've been Chief Exec of EYDAP for 6 years. How did you get to the role you're in today?
I actually started from Greece. I'm a mechanical and industrial engineer, got my MBA at Harvard Business School in the United States, and stayed in the United States for 27 years. I specialized in global information for energy, aerospace and defense, and construction. So I was running the largest companies in that space. After 27 years in the US, I came back to Greece because I had a very interesting proposal to run the Greek gas company called DEPA. I did that for about 5 years. And then I moved from gas to liquids. And here I am, the CEO of EYDAP.
So before you joined EYDAP, you'd not worked in water and wastewater.
That is correct. But don't forget that gas has networks. So it was a very smooth and interesting transition. Even the regulatory framework that we're using for water in Greece is pretty much exactly the same as the regulatory framework that we're using for energy. And again, when I was working for the construction information company in the US, I learned a lot about water infrastructure projects that were existing. And in water, after people, energy is one of the biggest costs that you have in the operation. So it all comes together, and it's actually quite exciting to get all that information and experience and put it together and apply it to the water business.
The excitement's coming through. I'm sensing it down the microphone. Now, EYDAP serves Athens, so we know where it serves. What we don't know is how many people it covers and what sort of assets you've got. Can you color that in for me? Tell me a bit more about the services you provide.
Sure. Athens is a city of about 5 million people. We serve about 2.2 million households with water that comes from the mountains about 300 kilometers away and comes with gravity. We currently have 4 reservoirs and the canals that bring the water to the city. We have 4 water treatment plants, 14,000 kilometers of water pipes. We have 5 wastewater treatment plants and about 10,000 kilometers of wastewater pipes. And we're building another 1,400 kilometers of wastewater pipes on the eastern side of the city. It's quite difficult because you have to weave through all the fiber networks and everything else that is in a modern city.
Yeah, you mentioned you've got 5 wastewater treatment works, and we're going to come to talking about one of them, because I believe you've got the second largest in Europe and some plans to make that net zero on energy generation. But before we get to that, I'd like to just start on the water supply side. The thing that everyone knows about Athens is it's one of these great ancient cities. It's been around for millennia. And here you are using, I'm sure, some of the infrastructure that dates back over those millennia. That getting the water down from the mountains to the city, I assume, is what the Romans were doing, maybe using slightly different aqueducts. But this must have been a similar process, I assume. Just talk me through some of the challenges that come with running a city that is ancient, not just medieval, but properly ancient.
We are indeed using a Roman aqueduct about 26 kilometers long to bring water to the city, and that existed about 2,000 years ago. We are dealing with the drought because now this old aqueduct is really only a drop in the bucket because Greece has increased significantly in population since the ancient times. A lot of infrastructure in Athens was built in the 60s. So now we have old pipes with increased tear and wear. So we have about a 200 million euro plan for replacing the pipes in the areas where they break most. And we have an investment plan to be ahead of the curve because we want to reduce our NRW. Our actual losses are about 15%, a little bit lower than the average from Europe, which is about 23%. And we want to take it down to around 10 to 12%. Now that's important because we had significant drought for 3 years. And if this continues for another 2 years, there are going to be significant issues. So we have the base plan, backup plan, and backup plan to the backup plan. So the base plan is actually an interesting idea, connecting our farthermost reservoir to a reservoir that is currently used for hydroelectric power. And it is only 30 kilometers away. We can access through the mountains through a series of 3 small 10-kilometer tunnels. The great thing about that is the capacity of that reservoir is 5 times the capacity of all of our reservoirs together. Most of that water will come with gravity, so relatively low cost.
Surely it's the drilling of a 30-mile long tunnel through the mountain that's going to be multi-billions.
Actually, not multi-billions, because 96 years ago, when we had the first reservoir for Athens, we built a tunnel to bring the water here that was 20 kilometers long. 50 years ago, when we built the further reservoir, we built 56 kilometers of tunnels. 30 years ago, when we built yet another reservoir, another 30 kilometers of tunnels. The great thing here is, with all the other projects, you had to build a reservoir as well. Here, in this case, you just have to build a tunnel. It's about a $500 million project. And the cost per cubic meter of that is 10 to 15 cents. And that's important to know, because the backup plan to that is desalination, which is 10 times that. And the backup plan to that is bringing from a river that is, again, about 300 kilometers away, using big tankers. There are a lot of big ship owners and they own tankers, so we could lease some of those big tankers to bring raw water to our canal, basically bypassing this tunnel that we want to create.
Now, you are 3 years into a drought, and in 2 years' time, if the drought continues, you'll be in dire straits. How long will it take to get the tunnel?
That's why we have the other plans. If you combine those actions with reducing the consumption, all of that make 2 years into 5 years, and the 5 years you could build the tunnel. The tunnel itself, because of the experience that we have, will take about 2 years to build. The whole idea is making sure that you can prepare all the studies and all the technical studies and be ready to drill.
Seldom have I heard a chief exec speak with such confidence, bearing in mind the potential looming catastrophe. It's great that you've got this sort of confidence around the plan, base plan, backup plan, backup plan.
The plans build the confidence. It's not me having the confidence.
Right. Well, let's now go to the wastewater side. You mentioned the extension of the network that you're doing for the western side of Athens. How many people are served currently? That would imply that not everybody's got a sewer network. Is that what you're correcting? Is that why the new network?
Yes, we are building wastewater network and 5 wastewater treatment plants. Actually, 2 of them are already running, and we're building another 3. There's a tender going on for the second one, a tender that is being completed for the first one of those 3, and then another one that we're going to be coming out with a tender in the next year or so.
And this will bring 100% of the population in that part into the sewer network?
Correct, like 90% to 95% into the sewer network, and we're going to be recycling all the water and using it for irrigation mainly. And also in that area, we're going to be using some of the recycled water for the data center they're building. We have a master plan for the eastern side of Athens. We are building now a master plan for the rest of Athens, because we have 300 million cubic meters of water that right now it's clean water and we throw it into the sea. Okay, let's bring that water back. Maybe, if it makes financial and economic sense, use it as recycled water for the needs and replace potable water with recycled water. If the cost is lower than the cost of 15 cents that I mentioned of the water that comes from the mountain.
So I wanted to touch on 3 topics. You've done 2 of them. The first is around your water supply resilience program. The second was around the extension of the wastewater network. The third one, however, is the one that's around the second largest wastewater treatment plant in Europe. Tell us what you're doing there and why that's so exciting.
So, Psyttalia is the second largest wastewater treatment plant in Europe. It's on an island, so you have finite space, so you cannot do different studies. You cannot build everything there. So you have to do all that together to figure out how you're going to place it on that little island. So one of the things is to take the water to 4-stage processing according to the European directives. So that's going to take some space. And the other thing is, instead of right now just using all the biogas to dry the sludge, because we have already used thermohydrolysis to increase the dry solids, we want to incinerate the piece of the biogas with the relatively dry sludge and produce the optimal amount of electricity and gas so that we can maximize the money that we can make by selling that in order to take that amount and lower tariffs to our consumers.
And you believe that this site, which is not small, this site could become energy net generative?
Correct. We've seen smaller similar sites in different parts of the world, and actually that's where we got the idea. For example, Hamburg. So we want to do that at a bigger scale, and we think it is possible. And it's going to be challenging, but really, really interesting.
Yeah, you should have a couple of things that work in your favor. One, of course, is the scale. If it works at a smaller scale, something like this, the economics should be even clearer at a bigger scale. The other thing which I'm thinking is that just the temperature of Athens, the ambient temperature must mean that it's easier to get to a drier cake that's going to combust than it would be if you were in, say, Norway. Common sense would suggest that, but I wonder.
I'd rather leave chemical engineering experts and the other experts figure out how to do that. But it brings up an interesting point, if I may say that, because of drought, everyone's thoughts are how to reduce water consumption. But we want to figure out, and especially this connection to this large reservoir that we want to accomplish, together with the water that we might get from Psyttalia. Together, these two could bring more water to the Athens area. The reason why I'm saying it's very important, because if you have more water, you can have more green. If you have more green, you can lower the temperature. Actually, we have another project trying to test the hypothesis. If you lower the temperature in Athens, you will have savings of energy, which are real cost savings, which may be larger than the cost of building the infrastructure to bring water here or to do all the things we talked about.
That is an inspiring point to finish on. And we always like to finish with a question. What advice would you give a young Harry if you could go back 20 years, 30 years, 40 years? You choose how far you want to go back, but what advice would you give a young Harry?
Well, I've learned over my career is that don't try to recreate everything, use best practices, figure out what they're doing around the world, learn from that and build on that. Because based on that, you can have smarter, faster, better ideas.
Thank you. You have been listening to the Exec Exchange with me, Piers Clark, and my guest today has been Harry Sachinis, the Chief Executive for EYDAP in Athens. I hope you can join us next time. Thank you.